My name is Jake Crimmins and I'm a world champion overclocker, and today I'm going to show you how I prepare my motherboards to run on liquid nitrogen. I'm going to go through insulating your motherboard to run your CPU on liquid nitrogen and show you what components you need. Here's a list of the supplies and components I used. A Kingpin Cooling Dragon F1 Extreme Edition CPU pot, EVGA Frostbite thermal paste, 1/2 inch closed cell foam insulation, blue shop towels, liquid nitrogen of course, a 1 liter thermos, 20 liter liquid nitrogen door, and a propane blowtorch. And here's the hardware I'm using. An Intel Core i7-990X Extreme Edition processor, an Asus Rampage 3 Black Edition, Asus ROG expander, 4 NVIDIA GeForce GTX 580s, a kit of Dominator GTX 2 memory, dual AX1200 power supplies, and a Force SSD. I start off by installing the backplate and the threaded rods. You'll notice I use blue shop towel and insulation between the motherboard and the backplate. This shop towel will help wick away any moisture that forms, which helps in preventing the death of your motherboard. With the backplate installed, I can start insulating the motherboard. For insulating around the CPU socket, I use a 1/2 inch closed cell foam, which I cut areas out of in order to fit capacitors and other components on the motherboard. I follow up with a second layer of closed cell foam with a cutout for the CPU. This helps prevent condensation from forming inside the CPU socket. Thermal paste is key in getting the most out of your hardware. I'm using EVGA's Frostbite thermal paste, which is a popular choice among overclockers. The next step is installing the Kingpin CPU cooling pot. It is already insulated with a layer of foam covered in electrical tape. This is what will get the CPU cold and give you your best overclocks. There's also a yellow K-type thermal probe already attached to the pot. This probe is used to measure the temperature at the base of the liquid nitrogen pot. I will also add another layer of foam to prevent condensation. Next, the hold down is installed. It has two main purposes. The first purpose is to keep the CPU pot on the CPU. The second is to push down on the insulation and give you a good seal. 4 springs and thumb nuts are used to keep this attached. While tightening the thumb nuts, I put pressure on the hold down to make sure the pot does not move and that it makes a good seat on the CPU. I'm using the Dominator GTX 2 modules for the best performance. I mount the motherboard on a test bench. This keeps everything organized and easily transportable. It already has my 2 AX1200s and my Force SSD installed. The only thing left to do is to plug in the graphics cards and all the cables. The ROG expander is installed on the motherboard to allow the video cards to run in 4-way SLI. It requires additional power, so the 4 Molex connectors are plugged in. Now we are ready to plug in our graphics cards. I start the machine up and let the CPU warm up, which helps the thermal paste set. I can then start pouring liquid nitrogen from the 1 liter thermos. I start cooling the CPU down to -50 degrees Celsius and then use the blowtorch to quickly heat it. This creates a layer of ice inside the pot, which acts as a buffer. This will help me keep the temperatures consistent while running a benchmark. I start pouring again until the temperature reaches -80 degrees Celsius. With the CPU cooled down, I can now start overclocking the memory and the CPU. I start with the baseline profile at 5 GHz and start working my way up from there. While I make these changes in the BIOS, I cool the CPU down to -100 degrees Celsius. You don't want to go too cold because you can cause an issue known as the cold boot bug. To demonstrate this, I got the CPU to -120 degrees Celsius and then tried to start the machine. The temperature was too cold to allow the CPU to start. That is why it's known as the cold boot bug. As you can see, the LED debug stops at 68. I use the blowtorch to heat the CPU up. This will allow the CPU to get warm enough to boot. Once the machine is posting successfully, I can start getting the CPU colder again. Once the machine is started again, you can normally get the CPU colder than the cold boot bug temperature, but you have to watch out for the cold bug. The cold bug is a temperature where the CPU just stops functioning. To demonstrate this, I'm going to run 3D Mark 11 and pour liquid nitrogen until the CPU locks up. As you can see, at negative 144 degrees Celsius, the CPU hit the cold bug. I'm going to use the blowtorch again to warm up the CPU and start overclocking. Now it's time to run the benchmark at the overclock settings. I ran the system earlier at stock clocks and got a 3D Mark 11 score of 15,373. With the CPU overclocked to 5.793 GHz, I was able to get a score of 20,339, which was good enough for a top 10 spot on the 3dmark.com Hall of Fame. For fun, I decided to see how far I could push my 990X. I used the ROG Connect function on my motherboard to connect it to my laptop and overclock from there. The max frequency ended up being just over 6 GHz. Thanks for watching, and if you want to learn more, you can read my articles on the Corsair blog or check out these overclocking forums.